In this problem, ABC is a triangle with AB equals 5 centimeters, AC equals 4 centimeters, and the angle A is equal to 50 degrees. And the question is to find BC. Of course, we will do it using the cosine rule, which we will prove using the dot product. So we have the dot product AB dot AC is equal to AB, the distance AB, times AC times cosine A. And we have the vector BC. The vector BC is equal to BE plus AC. Of course, it's equal to BE is minus AB, so minus AB plus AC plus AC. And rearranging, BC is equal to AC minus AB. Now, if we square both sides of this equality, we will have BC squared is equal to AC minus AB squared. So BC squared is equal to, of course, BC squared is BC dot BC, AC squared minus 2 AC dot AB, or AB dot AC is the same, AB, of course, plus AB squared, AB squared. But BC squared is equal to BC dot BC, or simply BC squared, the distance squared, is equal to AC squared, the same, AC dot AC, or the distance AC squared, minus 2 AC AB, or AB AC, minus 2 AB dot AC, AC dot AB is equal to AB dot AC, of course, plus AB squared, which is equal to the distance AB squared. And from here, we deduce the cosine rule. So the cosine rule is BC squared is equal to AB squared, starting with AB squared plus AC squared minus 2 AB dot AC minus 2, and AB dot AC is AB AC cosine A. Now the final step is to plug the values of our problem to get BC. So here BC squared is equal to AB squared, 5 squared, plus AC squared, 4 squared, minus 2 AB, 5, times AC, 4, times cosine A, so cosine 50 degrees. And using a calculator, BC squared is equal to 15.29, meaning that BC is equal to the square root of 15.29. So BC is approximately 3.91 centimeters. And this, of course, concludes our problem.